across this question in your forthcoming JAMB 2025, this is how you are going to solve it. With no further ado, let's get right into the video. A temperature of 20 degrees Celsius is the same as what? We have option A to be 36 degrees Fahrenheit, option B 68 degrees Fahrenheit, option C 11.1 degrees Fahrenheit, and option D 43.1 degrees Fahrenheit. For us to solve this question, the first thing that will come to your mind is this: we are comparing two scales, the Celsius scale and the Fahrenheit scale, and each of the scales has the upper fixed point and lower fixed point. So let's get started. Now this is a Celsius scale and this is a Fahrenheit scale, right? This is degree Celsius, degree Fahrenheit. The upper fixed point of Celsius scale is 100 degrees Celsius and the lower fixed point is 0 degrees Celsius. The upper fixed point of Fahrenheit scale is 212 degrees Fahrenheit and the lower fixed point is 32 degrees Fahrenheit. Now going back to the question, we are given the fundamental interval of 20 degrees Celsius. So here is what? 20 degrees Celsius. So we are looking for the equivalent of this temperature in degree Fahrenheit. Is it clear now? So what we are going to do is to use our formula, and the formula is fundamental interval minus lower fixed point, now divided by upper fixed point minus lower fixed point. Is that clear? Now what's the fundamental interval here? That is 20. Now we say this is 20 minus 0 divided by 100 minus 0, right? Now it's equals to theta minus 32 divided by 212 minus 32. Is that clear? Now let's work it out. 20 minus 0 is 20 divided by 100 minus 0 is 100. Now this is equals to theta minus 32 over 180, right? Now what do we do next? By saying cross multiply. So this is 100 bracket theta minus 32 is equals to 20 multiplied by 180. Okay, let's open up the bracket. We go by saying 100 multiplied by theta is 100 theta minus 100 multiplied by 32 is 3200. Then is equals to 20 multiplied by 180 is 3600, right? So what do? We say 100 theta is equals to, taking this one to the other side, that is 3600 plus 3200. Is that clear? So 100 theta is equals to 6800, right? By the time we divide by 100, this cancel out to give me theta, this cancel to give me what? 68 degree Fahrenheit. Is that clear now? Now from what we have gotten so far, the correct option to this question is option B. A thermometer with an arbitrary scale x of equal divisions, resistance minus 30 degree x at the ice point and plus 90 degree x at the steam point. Calculate the Celsius temperature corresponding to 60 degrees x. I have option A to be 25.0 degrees Celsius, option B to be 50.0 degrees Celsius, option C to be 66.7 degrees Celsius, option D to be 75.0 degrees Celsius. Now for us to be able to solve this, we should know that in this question, this thermometer we are talking about is what? Is labeled X, so it's measured in degree X. It's not in Celsius, it's not in Kelvin, it's not in Fahrenheit either. Okay, so we are going to note their upper fixed point and lower fixed point. That is the only thing that is important to us. Now let's go. This thermometer measured in degree X, the lower fixed point is minus 30 degree X, so this is minus 30 degree X. Okay, and the upper fixed point is 90. I'll have 90 degree X. Let me just add what? Plus. Okay, now we are looking at the Celsius temperature. I'm going to draw the Celsius scale, that is degrees Celsius. We should know that the degree Celsius, the upper fixed point is what? 100 and the lower fixed point is what? 0. Now this temperature we're looking for corresponds to what? 60 degree X. So that means they give us the fundamental interval of this particular thermometer. So here is 60 degrees X. You are looking for the equivalent in degree Celsius. You are going to use the formula which states that what? Fundamental interval minus lower fixed point divided by upper fixed point minus lower fixed point. Okay, and the fundamental interval here is what? 60. So let's go by saying 60 minus bracket minus 30. Okay, now divided by 90 minus bracket minus 30, right? Now this is equals to theta minus 0 all over 100 minus 0, right? So let's go by saying this is 60 minus times minus is plus, plus 30, okay, divided by 90 minus times minus is plus, we now have plus what? 30, right? Now this is equals to theta over what? 100, right? So let's add it together. So we say this is 90 over 120 is equals to theta over 100. So we can say cross multiply. If you say cross multiply, you're going to have 120 multiplied by theta is equals to 90 times 100, right? Now this is 120 theta is equals to 9,000. So we divide both sides by the coefficient of theta, which is 120. Okay, so theta is equals to 75 degrees Celsius. By the time you divide, this cancels this, right? 12 into itself 1, 12 into this is going to give me what? 75, right? And the answer is what? 75 degrees Celsius. So the correct option in this question is option D. The distance between the fixed point of centigrade thermometer is 20 centimeters. What is the temperature when the mercury level is 4.5 centimeter above the lower mark? Option A, 22.5 degrees Celsius. Option B, 29.0 degrees Celsius. Option C, 90.0 degrees Celsius. And option D, 100 degrees Celsius. For us to solve this quiz, we have to analyze it. Okay, now this is a centigrade thermometer, okay, and the distance between them, this is the upper fixed point and this is lower fixed point, right? The distance between them is given as what? 20 centimeters, right? Okay, what is the temperature when the mercury level reaches 4.5 centimeter above the lower mark? There is the lower mark. The lower mark is the lower fixed point, okay? Now from here to here, I have what? I have 4.5 centimeters. Now you're going to equate it to the centigrade thermometer. We have this. Upper fixed point is 100, lower fixed point is what? 0. And we are looking for this temperature. Now what are we going to do? You know, normally we used to say the fundamental interval subtracted by what? The lower fixed point. But now the distance is already given, so we don't need to subtract. Do you get what I just said? You don't need to subtract again because the distance between the fundamental interval and the lower fixed point of this centigrade thermometer is given as 4.5 centimeter. So you just have that by saying this is 4.5 divided by the difference between the upper fixed point and lower is given as 20. You now say divided by 20, right? Now this is equals to theta minus 0 all over 100 minus 0, right? So we get again by saying 4.5 over 20 is equals to theta over what? 100. We can say cross multiply 4.5 times 100 is equals to 20 what? Theta, right? Now multiply to have what? 450 is equals to 20 what? Theta. So divide both sides by the coefficient of theta, which is 20. This cancels this, right? Now theta is equals to 450 over 20, right? Then we cancel out. Then theta is equals, when you divide this, it's going to give us 22.5 degrees Celsius. So the correct option in this question is option A. What is the equivalent of 20 degrees Celsius in Kelvin scale? Option A, 293 Kelvin, option B 68 Kelvin, option C 36 Kelvin, and option D 20 Kelvin. We want to convert degrees Celsius to Kelvin simply by adding 273. So this absolute temperature, which is in Kelvin, is equals to the theta, which is degrees Celsius, plus what? 273 degrees Celsius. We are going to say that this is 20 degrees Celsius plus 273 degrees Celsius, right? And by the time we add, they are going to give us 293 Kelvin. So the correct option to this question is option A. If this video was helpful, please don't forget to subscribe to this channel, turn on the notification button to get notified each time I post videos, and lastly, do not forget to share so that other students can learn from there. I will see you next time in the next one. Bye for now.